And as a quick note with the integrated rate law, the differential rate law or the method of initial rates offers really obvious ways of dealing with multiple reactants. We hold one constant, we change the other and see what happens to the rate. However, in one graph, it's impossible for us to get the data on both things at the same time. So a method that we would use in that case is called flooding the reaction with one reactant. We'll actually, if we have time, do this with an experiment in class because it works really well. But what we try to do is keep the concentration of one thing so high relative to the other that it's pretty much constant. So although it's hard to keep a reactant constant over time because it will be consumed, if we talk about something that's 10 times, 100 times, or ideally 1,000 times more concentrated than the other chemical, even when that one is consumed, its concentration barely changes. And therefore, any concentration change wouldn't be reflected very much in the rate. The other thing would exhibit a very big change in concentration relative to the first, and we would be exploring how that change in concentration or natural log or reciprocal goes versus time. Once we have established that, we can go into a scenario maybe where we reverse our reactants or using the method of initial rates, but really we're trying to establish or create an experiment in a lab in which one thing can be tested at a time. You won't be asked for multiple sets of data to maybe sort your way through, but it is important to maybe be able to theoretically design an experiment where you take a single set of data and then use that to draw a conclusion, or more importantly, design an experiment where you could test your second set. And it's all about changing the concentration of one thing to watch that over time while keeping as many of the other variables, including the concentration of the other chemicals, constant.